nothing, I will kick this off. We're about 6 minutes past. So today we have about 53 minutes and some change. The idea is to have a really hands-on session diving into the query agent, showing how it works in different scenarios. If you're unfamiliar with the query agent is a agentic tool that we've launched to make queries much easier. And so a lot of what we'll be doing today is in JavaScript, by the way. I am Daniel Piri. I'll be helping facilitate this. I'm a developer experience engineer on the engineering team at Weaviate, and hopefully I can help you out. So like I mentioned, about 52 minutes, we'll go through the Weaviate Query Agent, some live coding, and then a bit of question and answer. So, is everyone familiar with JavaScript? No worries if not. The query agent is also available in TypeScript. So if you'd want to take a look at what the query agent rather enables, we can quickly go through this blog post. So Weaviate Query Agent. So introducing the query agent. And so essentially, this is something to help run queries across multiple collections in an agentic manner. So this is a little thing that we put together, and I will share a link to this in case you want to take a read. But I'll actually explain it in my slides. So you might know Weaviate for being your go-to database for things like semantic search, keyword retrieval, or hybrid retrieval, and maybe even RAG. And so the idea behind the query agent was to make all of this much easier by introducing an agentic workflow to how you interact with Weaviate. A lot of times our interactions with Weaviate were one-to-one, i.e. we make a specific query and we're always querying a specific collection or a specific tenant. Um, and for agentic platforms, that simply did not scale because there are some use cases where you have multiple collections and you want to be able to access a lot of collections, or at least you don't want to have to write or hard code this collection logic in your applications. And so the benefit of the query agent is it builds a brain, and this brain here is a large language model. And what that is, it exposes us to two tools. The first tool is a search tool, and the second is an aggregate tool. And so essentially, the large language model, i.e., the query agent, decides whether or not we should run a search or an aggregate or both over one or multiple collections. So whenever you interact with the query agent, you can read data from multiple collections, and the agent rather decides what tool is best to read for those collections. So we enter natural language queries like what shoes can I buy for over $60, for example. And the agent translates that query into a Weaviate query, decides if that natural language query, i.e., what shoes can I buy for over $60, is more of a search or more of an aggregate. In our case, this would be a search. Then this will look into what collections might actually be able to supply us the answer to that question, look in that question, analyze the response, and if it's valid, send it back to our user. And so it does a lot of the heavy lifting for us in terms of building our RAG pipelines. And so, like was mentioned earlier, if you're looking to go from a naive RAG where you simply pass all the context you get from a hybrid search, for example, to your large language model to then generate something, this sort of takes it a step further and upgrades that to an agentic RAG, where an agent decides what collections or what sort of data is useful for your application and for your user's query. So the idea, like I mentioned, behind the Weaviate Query Agent is to essentially have a large language model run or rather make decisions for us with respect to what searches we should run, what queries we should be making, and what tools we should be using. And so if you're looking to think about or rather, if you're trying to figure out why you should use something like Query Agent, if you're tired of having to think about something like that, or building an agent or an agentic application, this is the perfect thing to use for something like that. So, like I mentioned, based off whatever query you put into your based off whatever query you put into your agent, it decides what collections to access. At initialization, you give your agent access to multiple collections. And so based off of that configuration, it decides what collections you can access. It also determines if we need to run a semantic search, an aggregation, or both. Whatever is best for helping the user find out whatever type of data they're looking for. And then it also formulates its queries for the best performance in mind, i.e., it looks at whether I should include filters, what the right operator is, what the right keyword is based off whether it's a semantic search or a keyword search or a hybrid search, because the search queries for those things are actually quite different, and etc. And like I mentioned, it also determines what filters are right for each query. And then based off whatever answers it gets, it formulates an answer and sends that back to the user. Another really important distinction is looking at the difference between a search and an aggregate. A lot of times when we make a search, we're looking for specific results that we then send back. And these tend to be more rooted in natural language, whereas aggregate queries tend rather to be rooted in arithmetic. So if I'm asking something like, "Hey, um, what are the top five brands, or what brand has the most amount of sales, for example, or like what shoe brand has the most amount of sales?" That would be more of an aggregate because we'd look over multiple items and see and sort of sum up all of their sales to then see which one has the most sales, versus a search is more like, what shoe can I get for under $70? So that's just to help you understand the difference between the two. And what we'll be live coding today is a bit of an application. We'll be working with JavaScript, like I mentioned before. And essentially, our JavaScript application will be interacting with the query agent. We'll be using search and aggregates as the tools exposed to the query agent, and then accessing e-commerce and brand collections. So really important to actually use the query agent. We start by installing the agent's package on NPM. So the package is available in NPM if you want to try it out. Right now it's in alpha, which really just means that the API design is not set in stone. We will possibly be changing this design, and that's why we mentioned it being in alpha. So there's just sharing that if you want to take a look. Alongside the agents package, you want to have the Weaviate JavaScript client installed. So I'll share this. And so once we have those two things installed, we can then run and use the query agent. Essentially, what the query agent does is it piggybacks off of essentially what the query agent does is piggybacks off of the client initialization that we make with the Weaviate client. And so when you install this Weaviate agents package, you pass in a client object, and that client object is what's used to interact with the agent. So let's get straight into our live coding. And so we'll make a couple of assumptions before we get started. I'll assume that I already have data running. So let's run code. That's great. So now that this is open, we'll create a query agent of our own. And so what I'm working with here, and I'll zoom in, is a recipes repository. If you're new to Weaviate building in JavaScript, this is one of the best resources that you can use. It is a repository of multiple recipes, which essentially are end-to-end scripts that help you run different or test out rather different features and tools that work with Weaviate, covering things from similarity search to multimodality, migration, different integrations with tools like Llama Index. We'll be adding things like Mastra and LangChain very soon, hybrid search, generative search, and of course, agents. And so this is where our code will be. We'll be working with the agents folder. So if we get time, I might work on integrating the query agent into a Llama index agentic workflow. But the bare minimum for today will be using the Weaviate query agent on its own in isolation. So I'll run through this load.ts file. Let me know if this is too big for you, and I will sort of zoom out. And so the first thing that we want to do if we're using the query agent is to get data into Weaviate. That's one of the most important things. You can't query something when you don't have any data. Also, just as I keep going, if you have any questions, please feel free to drop them in the main chat, and I'll try and get them as I go along. So I'll try and keep this as basic as possible. So essentially here we have a import. And so essentially we're importing our Weaviate client because we want to put data into Weaviate. We have a main function, and this main function initializes a connection to Weaviate Cloud. And in this connection, we pass our auth credentials because we're using the Weaviate Cloud, and then call a function called populate Weaviate. Now, populate Weaviate is where things get interesting. We initialize 3 collections. If you're new to Weaviate, a collection is essentially like a table in a relational database. And so what we're doing is we're deleting any collections if they exist, only if, excuse me, only if we have the overwrite existing flag as true. At the moment, it's false. Essentially, we're doing this because if you try and create a collection when it already exists, Weaviate will send you an error, and we are going to create some collections. So here we have our creation object. And so when using the Weaviate query agent, there's a couple things in mind you have to pay attention to. The first being how you define your collection. If you're already familiar with how to define a collection, that's fine. It's really mostly what I'm about to share really is mostly an extension of what you already know. And so if you're doing anything with agents, they benefit from as much information as possible. And so that's why you see here, we describe or rather add descriptions to both our collections and the properties. So I'll quickly just go over what we're doing here. So we're creating a collection called e-commerce. We describe this collection as a data set that lists clothing items, their brands, prices, and more. We create a vectorizer. Essentially, this is an embedding model that creates a vector representation of any data that you feed into it. So we have text-to-vec Weaviate, text-to-vec Weaviate, and essentially we're creating a vector representation of the description of a clothing item. And then we're also creating a separate vector representation for the name, description, and brand. So once we do that, we then describe the various properties in this data set. Before we dive into these, I want to actually look at the data that we're working with. So we're using Hugging Face datasets, and we have an open data set if you would like to play around with this. All of this is linked, but I'll just share this in the chat as well. So essentially, we have a bunch of different data sets. The one you looked at was the brands dataset, or rather the e-commerce one. So we have the e-commerce dataset, and so you can see we have a name, description, collection, a URL, and some sort of review of that, as well as a vector representation. So you don't necessarily have to create that representation, at least when you're working with this dataset. Right. Besides that tangent, let's get back to explaining our collection creation. So essentially, what we do is then describe each of the properties in this collection. And you can see that for category, we add a description. Description has a description, tags, sorry, has a description. And essentially, these are all nuggets that the agent can use to decide what the best tool property collection is to help serve you best. So things like price here, the price of clothing in USD, the fact that we include the currency USD is also something that the agent can look at when it's thinking through what the best solution is. So that's the first collection we create. We also create a collection called weather, like we did previously. We create a description, or rather define a description, and we give our temperature a description as well. So temperature value in degrees Celsius. Great. So essentially we do the same, excuse me, for financial contracts, and then essentially run this load data set, which downloads all the data from Hugging Face and puts it into Weaviate. Now we'll explore my Weaviate because we already have something. So just so we can see that we actually are already working with Weaviate, I will copy this code and run a query so we can see that we actually already have data in Weaviate. So let's create a new file. So I'll just call this fetch.ts. I'll paste our imports. I don't need this. I will close that. And I'll define 3 variables. So collection.use. So we defined e-commerce. We defined a financial contracts. And we defined something called, what was the third one? Our third thing that we created was, where is that? Yeah, weather. Great. I could just copy that. I think that makes more sense. So essentially what we're doing here is defining a variable that we can use to make a query. And so we'll say const e-commerce, I'll use abbreviation, ECC for e-commerce collection, response is equal to our e-commerce collection dot query dot fetch objects. So essentially what I'll do is I will limit this to the first 10 objects and first 3. This is just so we can see that we actually have objects, and console log that data. And go to await this. So let's run this in our terminal. Just zoom in a bit. And we'll run npx tsx, and we're working in the agents folder. We're working with Weaviate agents and the query agent, and we want to run fetch.ts so you can actually see what objects we're working with. Oops, it looks like I did not call the main function. So void main, and I'll just describe our console log here. Objects fetched. Right, that's why nothing was output. And if we actually want to see something, we have to specify .objects. So just so we can see that we actually have data. So here you can see our properties. We have a skirt, we have a coat, and we have, what else do we have? Is this under name? And we have a soft earth denim, sorry. So essentially, yes, we have data in our collections, and that's the only reason why I run that. So you can see that after running this, you will have data in your collections. Now, after we've populated data, um, what we want to do is essentially start making queries. So this file, run.ts, is where we'll make our queries. We have a main function, as we did before, and essentially this query agent is one of the classes that we use to build out our use of the Weaviate agent, Weaviate Query Agent. Like I mentioned, we always run this alongside the Weaviate client. So like we always do, initialize a connection to our Weaviate cloud, and then initialize a query agent with a specific configuration. And so for e-commerce specifically, we're saying new query agent, and then we pass in a client object and the collections that we want to work with. So we could absolutely get rid of multiple collections. So we could get rid of, for example, this e-commerce application, and that should work perfectly. I have a couple queries here already I ran, and let's just comment everything below here. Does that work? Yeah, let's comment everything below here and type out our own query. And let's see, it's const weather query. So let's actually fetch data and see what we have in our weather collection. So weather collection response. Let's see what type of data, and then we can start to figure out oh, there we go. Right, so we have wind speed, visibility, pressure, temperature, and these are some of the properties that we have. So we can start to ask things like, I think one of the things that this agent is good at is exploring your data. So we could say something like const weather response is equal to this QA config. So query agent with config, we're passing the financial contracts and the weather, and we'll pass in our weather query and choose the collections that we want to interact with. Let's get rid of what is the weather in New York and say what is the average. Let's look at our data again. So temperature, wind speed. So we could say something like, what was the lowest temperature in May, for example, in 2023? What was the lowest temperature in 2023? That's not temperature. There we go. And then this weather response we want to display. So we have a very nice helper function called display, which will log our response. And when we get that response, you'll see how interesting this agent can be. So let's go run this. I'll just clear my screen for a bit and type run.ts. So it takes quite some time to run. I think about 5 to 10 seconds because there's lots of back and forth with queries. Right, so here we can see, and we can see what our response is. And this is a great opportunity to explore the response object from our query. So one of the things that we get back is the original query. So this is what the user put in. And so we entered what was the lowest temperature in 2023. And we get the collection that was used when this query was made, any searches that were made, and then any aggregates that happened. So previously, when I shared slides, I sort of talked about the difference between aggregations and searches, where a lot of aggregations tend to be rooted in arithmetic and numerical calculations versus searches being more keyword based and rooted in text. So you can see we run an aggregate on the weather collection, on the property temperature, and we looked for the minimum as a metric. So the minimum value of all the temperature values is what we looked for, or rather what the agent decided was the best thing to use it. And essentially it ran a filter because I did specify what was the lowest temperature in 2023. It also included a filter that added the first day of 2023 to the last day of 2023. And so you can see all of that information is included in that aggregation. And then for usage and I guess statistics, you get to see how many requests were made, how many tokens were used up in that request, how many tokens were used in the response, how many tokens in general were used, as well as how much time it took for that answer to come, the answer from the actual aggregation, and then the actual answer generated from a large language model. So these are all things that we have. And you can see here our sources is quite blank. So if we go back and change what our query is from what is the lowest temperature in May 2023, we could sort of say what day had so we could say will it rain? And so this is something you can see where the will it rain in May 2023? Or did it rain? Because that's the past. Let's run that. And so there's this assumption that the model understands that precipitation equals rain. Ooh. Interesting error I have not seen before. Will it rain in May 2023? Let's try that again. Oh, in all of my very thorough testing, I have not come across this error. So that is good to see. I'll just take note quickly of what I typed and give this as feedback. Over weather connection. Okay. And it seems to not like this. So what we'll do is we'll get back to our collection here and we'll add our e-commerce collection. I believe this is how it was spelled, e-commerce. Yes. And we change our weather query and change this to query response. So query response, just right. So query, and we'll change this to our normal query. And this query says, I like vintage clothes and nice shoes. Recommend some of each below $60. So let's run this so you can see the search functionality that is enabled in the query. Oh, it looks like there is a problem with the client. I will just test something really quickly. Ah, yes, sorry. Before I do that, I actually made a mistake on the collection I was exposing. So I've actually added the e-commerce client. Oh, just take a look at something really quickly. Okay, that's very weird. Let me see if there were any pushes made. That might be okay. There's definitely some changes, but let's try and read through this error that we're getting. Error while searching Weaviate collection, details, collection, name, e-commerce. Right, looks like we have a problem with this collection name. Maybe we need to specify. Oh, yes. It's because we did not specify what target vector we were searching through. So when I run this now, we should get it working as expected. Okay, we have a new error, which means we're making progress. No target vectors were provided. Doop, doop, doop. Right, so in my query, I need to specify what collection I want to interact with if I define that collection. But if I get rid of that e-commerce, it should use what I defined in my configuration. And then that should work. So we got some troubleshooting for free here. Right, so here we go. Now we have our output. And like we saw previously, we have our original vector, or rather our original query, which was, I like vintage clothes and nice shoes. Recommend some of each below $60. It shows what collection name we searched through. And unlike the previous query, which was more of a, unlike the previous query, which was more of an aggregation, this is actually a natural language query. And so we can see that we had our search query as vintage clothes under $60. And then here we run a couple filters. And our query was nice shoes on this collection. And we looked for a property name. We looked rather for category and used the like operator of shoes and nice, as well as a description and a name of shoes and nice. So we're basically searching for anything that says nice or shoes on either the name of an object or a description or the category. And so the query agent essentially creates all of these um, filters, which can help us find in a much better way exactly what we're looking for. We get more information here on exactly what we're doing. So the usage, no aggregations were run. And importantly here, we start to see something that we haven't seen before. Besides the total time, we have a property called has search answer, which is true. And then we have a property called is partial answer, which essentially tells us if the agent did not have enough information to confidently answer our question. That is set to true, and then we have an array of missing information, which we set to specific recommendations for shoes under $60. So while it does return something, it doesn't necessarily have all the information it needs to give us a confident answer on re recommendations for nice shoes under $60. And then, of course, we have our final answer, and we include the sources that helped um, sort of inform this final answer. And so that's one really interesting part of the query agent. Or we could also run an aggregate query and see essentially what is the name of the brand that lists the most shoes. So it will look over all the shoe brands, and look for the brand that has shoes, and it reports that to us. So it says there is no available information on the brand of the list of most shoes in the provided data, which is also behavior we want. If we don't necessarily find something in the data we're looking for, that's fine. Right. So we'll comment this out and skip to this concept of follow-up queries. And so essentially one really cool thing that the agent can do is follow up answers. So previous responses that we got, and then run a similar search. So I'll comment this out. And I already have an example here of where this is used. So we have a very basic query that we're basically asking the agent saying, I like vintage clothes and nice shoes. Could you please recommend some of each below $60, which was the previous query that we ran, and this was the answer we got. We're displaying that and then making a follow-up query and passing in the context from the previous response as information for the agent to consider as it services this query. So I like the vintage clothes options. Can you do the same again, but for anything above $200? So let's run this and then we'll see the differences in the responses that the agent gives us. So it should take about 10 seconds or so. Yep, 7 seconds. Right. I forgot to save. Okay, let's run that again. So first things first, we already see that it gives us a response for vintage clothes under $60. But then you see our follow-up request here is, and can you give me anything above $200? Um, so it tells you also the missing information, which was the variety of vintage clothing options above $200 beyond the single item bound. So there's only one item found of $200. And we could actually test this with an aggregate query. How many items? How many vintage clothing items? How many cost more than $200? So we'll use that as a follow-up. And I think we're almost out of time. So I'll start to wrap up pretty quickly. So you can see we got that result for the vintage clothes under 60. And then boop, boop, boop. So we get an error here on the IDs provided. Just covering a lot of, so aggregation error, right? So essentially, we're not necessarily providing the amount. So let's look at the e-commerce collection and all the properties in it so we can actually properly inform. So we run fetch objects on e-commerce. And this just goes to show that you have to price. So it would be nice if we gave this access to the price as well. So maybe the price could be useful. Yeah, I think price is the only other thing that we need. Okay, so let's run our previous query again. And now that we've saved that, our agent should have access to the price of objects and then would be able to answer our question here. Right, so we get that answer for the first query. And moment of truth. Boom. There we go. So this just goes to show how important that configuration is, both at query time and at configuration time. Our agent can only deal with whatever data we give it. And so because it didn't have any access to the price, it wasn't able to run an aggregate on the cost of something. When we gave it access to that price, it was able to see that we actually had items over $200. So there we go. Which also sort of invalidates our previous response when the agent didn't have access to the price of something. But at the moment, this is what you can do with the query agent. You can build this into an API, into a front-end application. I feel like it's pretty powerful and will help sort of take your RAG implementations to hopefully another level. So let's look at what's coming. We just had a release, which is why I was checking GitHub on the agents. So we have better types. We'll be able to stream method, rather we'll be able to stream data from the agent. And we fix some of the typing progress and a couple other things. So keep an eye on this agent's NPM page. You should see a couple of releases coming up. And of course, as always, you have access to the recipes folder if you are eager to try that out. We'll be constantly adding new recipes to both the Llama index agents as well as the Weaviate agents. I'll also share the agents documentation page in the chat in case you're curious and would like to read up on the theory behind it or reference it. That's pretty much it for this. We have about 8 minutes. I just want to share that next week, Tuesday, so essentially a week from now, we'll be running another workshop, an online workshop on Agentic RAG workflows with Weaviate in JavaScript. I'll be hosting that session on Zoom. And we have a lot more workshops coming up. So if you would like to keep track of that, this is the perfect place to do that. You can find me in the company Slack as well as the community Slack and online as Malgambes. Thank you so much for attending.